Hi, this is your calibration mentor, and on this video, I'm going to teach you on how to calibrate a digital micrometer. Calibration of digital micrometer. What is micrometer? A micrometer is an instrument used for making precise linear measurements of dimensions such as diameter, thickness, and length of solid bodies. There are a lot of different types of micrometers, but in this video, we will just focus on digital type micrometer. First of all, we need to prepare our calibration standards and accessories and cleaning materials. For standards and accessories to be used, gauge block set, grade 0 or 1, thermohygrometer, micrometer holder, ethanol, nitrile gloves, and lint-free cloth or paper. Take note to always wear gloves or finger cuts before handling the micrometer. This is to ensure that the dirt, dust, oil, or other foreign particles from the micrometer will not be transferred to you or vice versa. After preparation, we need to undergo pre-calibration checking. First, check the micrometer for any missing or defective parts. Second, check for any abnormalities on the display when turned on. The display should be clear and readable. Change the battery if necessary. Third, check if the micrometer can move smoothly throughout the entire range. Fourth, check if the ratchet stop or friction stop is working. The micrometer will produce sound when you turn the ratchets while the micrometer is closed. We need to do checking of the micrometer before we do the calibration. This is to ensure that the micrometer is suited for calibration. We will show you a sample video on how to do the pre-calibration check. Pre-calibration checking, now it's time to do cleaning of the micrometer and the standard gauge block. Here is the procedure on how to clean the micrometer. First, clean all the surface of the micrometer for any foreign particles or dust that may be present in the instrument. Use ethanol and lint-free cloth or paper. Second, place the micrometer to the holder. When attaching the micrometer onto the micrometer stand, the stand should be clamped to the center of the micrometer frame. Do not clamp it too tightly. Third, clean the measuring face of the micrometer by putting lint-free cloth or paper in between the anvils and carefully pull it out. Here is the sample video on how to clean the micrometer. before cleaning the gauge block, we need to clean the measuring face of the gauge block. Use ethanol and lint-free cloth or paper to remove any dust. Wiping of measuring surface should be done in one direction only. Next, place the clean gauge block to a tray. Clean gauge blocks must be separated from the set so that it will not mix up to the unclean gauge blocks. The next video is the actual cleaning of gauge block. After cleaning, stabilization must perform prior calibration. Allow the micrometer and the gauge block to stabilize in the laboratory environmental condition for temperature 20 degrees Celsius plus minus 1 degree Celsius. Relative humidity 55% RH plus minus 15% RH. This is to minimize the effect of thermal expansion of the gauge block that may contribute to the measurement during calibration. It is known that metals don't expand and contract at 20 degrees temperature. Now we will proceed for the calibration procedure. Use reference standard GISB 7502 calibration of micrometers. Parameters to be checked are instrumental error and parallelism of the measuring phase. Now we proceed to instrumental error. Instrumental error test is used to determine if the micrometer is still within allowable error throughout the entire measuring range. You can see the measuring range of the micrometer and the instrumental error based on GIS 7502. This is the procedure on how to determine the instrumental error of the micrometer. First, record the temperature of the relative humidity as initial environmental condition. Second, start the calibration by zeroing the micrometer. Close the micrometer until the moving anvil touches the fixed anvil and set the ratchet stop to 3 clicks. Press the origin button until the INC display disappears. Third, measure the first calibration point 2.5 mm and make 5 readings. Gently rock the gauge block to and fro when setting the gauge block for measurement. This is to properly align the gauge block with the measuring face of the anvil. The 3 clicks used during zeroing is to be applied to all calibration points during measurements. Always use the ratchet stop of the micrometer when making measurement. This is to ensure that we are applying a constant force when making measurement. There is no specific reason why we use 3 clicks. We just want to establish a good measurement practice. It is always up to the technician if how many clicks to be used. Fourth, get the average of the 5 readings. The average should be within the plus or minus 0.002 mm of the calibration point. Fifth, repeat the measurement of step 2 for the remaining calibration points. And lastly, after all calibration points is done, record the temperature and the relative humidity as final environmental condition. Take note that the temperature difference of the final and initial environmental condition must not be more than 1 degree Celsius. Otherwise, the calibration process shall be repeated. Following the GIS recommendation for the calibration points for the calibration of micrometer. These points are 2.5 mm, 5.1 mm, 10.3 mm, 12.9 mm, 15 mm, 17.6 mm, 20.2 mm, 22.8 mm, and 25 mm. According to GIS, these points are preferably selected so that these are capable of obtaining errors for not only the position for integer rotation of the spindle but also for the intermediate position. Next is the actual video on how to determine the instrumental error of micrometer. Next is parallelism of the measuring phase. 1 mm gauge block will be used and interposed to different location of the micrometer measuring phase. This is to determine the error of each location from the center of the measuring phase. Next is the procedure of the parallelism of the measuring phase. First, start the calibration by zeroing the micrometer. Close the micrometer until the moving anvil touches the fixed anvil and set the ratchet stop to 3 clicks. Press the origin button until the INC display disappears. Second, place 1 mm gauge block to position 1 and record the reading. Third, interpose the gauge block 1 mm between the measuring phases of the micrometer and record the readings. You must gently rock the gauge block to and fro when setting the gauge block for measurement. This is to properly align the gauge block with the measuring phase of the anvil. The 3 clicks used during zeroing is to be applied to all positions of the measuring phase. Follow the sequence of interposing the gauge block according to the figure presented. And lastly, get the difference of the maximum and the minimum reading as the parallelism error. Parallelism error should not be more than 0.002 mm. For the last video, this is to show you the actual procedure for the parallelism of the measuring phase. And that's it. Now you have your micrometer calibrated. Thanks for watching. Please subscribe and hit the notification bell for you to be updated for our upcoming videos. Thank you!